concept. Okay. Hey guys. Look, we are now looking at our 7C.1 video. I'm letting you know this video I am creating at home off of a computer screen instead of like I usually do off the big board. So the writing is going to be a little bit rough. Or at least more rough than you're used to. Okay. So, overall it'll be fine though. So what we're doing in Target 7C is using special right triangles to solve for sides. Okay. So we have a 45, 45, 90 triangle. That's the first triangle we're going to look at. And what that refers to is the angles. Ooh, that's not what I want this. Okay, so it's 45 degrees, and 90 degrees. Okay, so you can see that here. And our special right triangle, right, just means that we know the different sides are already, right? We have two special right triangles that we know and we can use to figure out all the other ones. So the legs in a special right triangle are, in a 45, 45, 90 degree triangle are the same. And we say this leg equals 1 and this leg equals a length of 1. So both of our legs are 1. Our hypotenuse is the square root of 2. Okay. So hypotenuse equals the square root of 2 and leg equals 1. You do not have to memorize this triangle. This triangle is given to you. It is also given to you on the SAT if you have problems similar to this on the SAT. Okay? But if we have a triangle where I only know one of my sides. Okay? And I'm going to make this a little smaller so I can see both of these. If you look at these triangles, right, this triangle has a 45 degree angle and a 45 degree angle that's congruent and another angle that's congruent and a right angle that's congruent. Right? So all the angles in these two triangles are congruent, and so therefore these triangles are similar. Triangles, this is still hard work. With congruent angles and that's using stuff from KC6. Okay, so just kind of remembering that triangles with congruent angles are similar, going back to KC6. Okay, so now what I'm going to do is I'm going to solve for one angle at a time. I'm going to first solve for so I'm going to take this P and if I look back at my this triangle is similar to this triangle. So we're calling this our new and this original triangle our old. So we're doing new over old just like we did last unit. Okay? So we have P and this P is between the right angle and a 45 degree angle. So between the right angle and the 45 degree angle on this triangle is the number 1. So this will be P over 1. Okay. Equals. Now here, right, I could then either choose R or 7. Well, I'm going to choose 7 because it's an actual number. Okay, I can't have two variables. 7 is also between a right angle and a 45-degree angle. So between my right angle and my 45-degree angle is also the number 1. Okay. And now just like in KC6, I'm cross multiplying. So I have 1 times P, which is P, equals 1 times 7, which is 7. So P equals 7. Okay. Okay, now we have to do the same idea, but for R. So I have R over, right? Well, if I look, R is the hypotenuse. It's between 45 degrees and 45 degrees. And here I have square root 2. Sorry. And then I'm going to set it up with the same one, right? So I have 7 over 1. So whatever this was, you'll use it both times if you're solving for two things. Okay. So same thing, I have R times 1, which is just R, equals 7 times square root 2. Now remember, one of these is a square root, and one of them is not, and we can't multiply, right, things inside the square root and outside the square root. That's actually going all the way back to our first unit in KC1. Okay, so we're just going to leave it like this. R equals 7 square root 2. So a lot of this is just going back to our stuff from KC6 with similar right triangles. All right, let's look at our next one. We'll solve for y first. It really doesn't matter which one you solve for first. Okay. And y is between your 45-degree angle and your 90-degree angle. So again, if I look back up top, between my 45 and my 90 is a leg, which is 1. And then this is 8. And it's between our 45 and our 45. Again, I'm choosing the 8 because it's a number. Z is not a number. It's another variable. So I have to use 8. Let me write that better. Doesn't like 8s. Okay. And then between the two 45-degree angles, right, is our hypotenuse. So it goes with square root 2. Okay, so we're kind of, again, matching up our triangles, playing our matching game. Once I have that, once again, I'm just going to cross multiply. So I have y times square root 2 equals 8 times 1. So y times square root 2 equals 8. I'm going to divide by square root 2. So y equals 8 over square root 2. Now, I would accept this answer, but we're using Delta Math for our activities right now. And right now, Delta Math wants us to do what we call rationalize the denominator. So, if you have a denominator with a square root in it. So, let's use like that. We don't like that. So, on the website with like the activity, I'm going to post the link for this calculator that will help you. It's Math Portal. It's rationalize your radical denominator. And all you're going to put in is, for my numerator, if we look, our numerator, the number on top is 8. And my denominator is the square root of 2. And if you read, they replace the square root sign with the letter R. So it's the square root, so I'm just going to put R of 2. Check here to make sure it looks like what yours looks like, 8 root 2. And then click rationalize denominator. There it goes. And then it gives you 8 over root 2 is actually 4 root 2. Okay, it's a weird trick. I'm not really going to worry about it, which is why I'm just allowing you to use the online piece. Sorry. Okay. So we'll just have okay, and again, this comes from the online calculator. Okay. Now I'm going to do the same thing with Z, which is also a leg. Since it's also a leg, Z is also over 1. And then I have my number 8. Okay. One thing to notice that this is the same problem now. So I have Z times square root 2 equals 8 times 1. I could continue to do this work, or I can just know, oh, my legs are going to be congruent. Right? That's something we talked about up here, right? Your two legs are exactly the same. Whatever your first leg is what your second leg is as well. Okay? Alright. Let's look at one more. Maybe. Well, let's look at both of these. Okay. So here, we'll solve for x first. X is a leg, right? If this is my 90, this is 45, then this is also 45 degrees. Okay. And again, my legs are 1, so it's x over 1 equals, this is also a leg. So x, switch colors. So when we cross multiply, we get x equals, well, 1 times 4 square root 3 is just going to be 4 square root 3, right? Because 1 times 4 is 4, and we have the square root 3. Right? Or again, this leg and this leg are going to be exactly the same. The legs are congruent. Okay. Let's look at our y then, which is our part of our hypotenuse. So y goes with our hypotenuse in our original triangle. And remember, your hypotenuse is square root 2. And then I have 4 square root 3 over 1, right? It's always equal to the same thing. So I have y equals, right, because y times 1 is y. Well, 4 times square root 3 times square root 2. These are the two I can actually multiply. 4 does not have a square root. It's different from the others. Square root 3 times square root 2 is square root 6. Done. Okay. Alright, last one, really quick. We're going to solve for x first. X is a leg, so that's x over 1. Our number here is 2 square root 2. Over square root 2. Because that is a hypotenuse. So when I cross multiply, I get x times square root 2 equals, well, 1 times 2 is 2 square root 2. In order to solve for x, I'm going to divide by root 2. Here it's nice and easy. These just cancel. Right? So I'm left with just x equals 2. Well, this is also the same. This is also x. So the other x also equals 2. Alright, that is it. For C1, there is no individual activity for C1. So if you're done with that, you can go ahead and start working on the C2 notes and then do the activity that covers both of them. Hope you guys are staying safe, washing your hands, and have a good rest of your day.